Alrighty, let's take a look at some more advanced integration techniques. We are going to talk about integrating inverse trigonometric functions and integrating by completing the square. So we have to have memorized these three, and frankly, these two are the main ones that you'll have memorized. But basically, you should know that since the derivative of arctan is 1 over 1 plus x squared, that the reverse holds, that the integral of 1 over 1 plus x squared is arctan. Don't forget the plus c. And since the derivative of arcsine is 1 over the square root of 1 minus x squared, that when you integrate 1 over the square root of 1 minus x squared, you integrate to arcsine of x, of course, plus c. This one is less important because it's just the negation of the arcsine. So you can really just work with arcsine and negate out in front if you need to. This is just here for an FYI. So let's combine our knowledge of these integrals along with the process of u sub to integrate more complicated fractions into inverse trig functions. So if you're faced with the integral of 1 over 9 plus x squared, you ought to look at this, or your job is to look at this and think, okay, that kind of looks like 1 over 1 plus x squared, but it's not. So I actually need to do something to change it to make it so that we can integrate into arctan. So the way that we manipulate this is that we factor a 9 out of the denominator. And in fact, what's easiest is just to take this out in front as a 1/9. And then you'll want to rewrite x squared over 9 as x over 3 all squared, and we end up with this expression right here. So now you can use u substitution, where your u is x over 3, and then your du is 1/3 dx. But you need to have dx alone to sub into right here, so you're ending up multiplying by 3 to get 3 du equals dx. So when I do u substitution into here, I have to multiply by a 3 out in front, and then instead of x over 3 squared, I have just u squared. So my 3 out in front times 1/9 gave me 1/3, and then this is going to now integrate to arctan. So when I integrate this, I'm going to get 1/3 arctan of u plus c, and of course now I need to resubstitute in for u, so my final answer is 1/3 arctan of x over 3 plus c. And that's what I wrote right here, so I've just written it twice for you. So let's practice. Find the general antiderivative, of course that means have a plus c, of the integral of 1 over the square root of 16 minus x squared. So you should recognize this as somewhat close to arcsine. So we know that we're going to use arcsine as quote unquote the core antiderivative. And what we need to do is factor 16 out of this square root. So in the integral, underneath the radical, we are going to pull out a 16 and be left with 1 minus x squared over 16. Okay, and then the square root of 16 can come out in front to be 1/4, and don't forget, of course, this is an integral. So you have 1/4 out in front of your integral symbol, and now you have 1 over the square root of, and it's 1 minus x squared over 16, but I know that x squared over 16 is really x over 4 all squared. So I have a dx here, and underneath my radical, I'll be left with 1 minus x over 4 squared. And now I can use u substitution. And so my u is going to be the x over 4. And when I differentiate to get du, I get 1/4 dx, but I just needed a plain dx, so I need to actually multiply both sides by 4. So 4 du equals dx. So when I substitute in here, I have to multiply the 1/4 out in front by this 4. So I just get a constant of 1 out in front. And then I'm integrating 1 over the square root of 1 minus u squared, and now I have du. This integrates to arcsine. Arcsine of u plus c, but of course I need to resubstitute in for my u value, and my final answer is going to be arcsine of x over 4 plus c.